Before starting off, I just want to say that please do not replicate this at home. I'm setting my own life at the line for your entertainment and education, and please do not what you see, because I'm actually going to be producing a dangerous chemical here. And now let's get started. Hey guys, in this video I'm going to show you how I created copper hydroxide at home. Basically, the reason I'm doing it is because it looks really beautiful. It's like this light blue, kind of greenish color. And how I discovered the process is completely by accident. I was doing electrolysis, which is right now another project of mine, which I kind of don't want to finish because it's not going well. And I was doing it wrong, kind of, and then I discovered that, you know, when you do it like this and this, it makes a really beautiful compound. And now I'm going to show you how it all works, and I hope you enjoy the video. By the way, if you have no interest whatsoever watching the whole part where I explain the chemistry, skip to this second and minute, I guess. So, here's how it looks. I basically had this apparatus for the electrolysis. Basically, it's just a jar with two wires coming in, okay? By the way, the blue there is the insulation, and the green, and yellow is for the copper, which is, I know, a really bad color for yellow. For copper. But I maybe should have chosen orange, but I don't have orange right now, so not important, basically. And this was then in a solution of water and sodium bicarbonate with the formula NaHCO3, okay? Basically, more commonly known as baking soda. Oh, why is my phone so... Now, basically, this worked out perfectly. So, if I put the sodium bicarbonate in water, what happens is this. Wait, let me write this down really quickly. This breaks down in water into some sodium ions, which are positively charged, and some bicarbonates, which are... Do they have any charge? Damn! I'm sorry. Wait, hold up just a second. I'm getting some tape. You know, this contraption is really shit, actually. Damn! Again? So, now I've taped my phone onto this shitty apparatus that I built. So, basically, we can basically leave out the sodium ions, but the bicarbonate again reacts with the water, formula H2O, to make some hydroxide and hydrogen bicarbonate. Okay? And now we can leave out the hydrogen bicarbonate. We only care about the hydroxide. So, and then, not dependent on this one, the copper, if you perform electrolysis with it, it breaks down into a positive copper ion and two electrons, which are negatively charged. So basically what this tells us is that when you perform electrolysis with copper, the copper loses two electrons, which then go away in the form of, well, two electrons. And then we can basically ignore the electrons, because they will then go to the cathode, I think it was. And the copper ions then react with the hydroxide to form, not an equal sign, I need to use this, to create the thing we want, copper hydroxide. You know, basically that this all was a happy accident is just so beautiful. It works out perfectly. Like, the fact that this is like just an accident, this is insane. So now let's try it out again to see if I can replicate the results. Oh no, by the way, I have to tell you something before. This component that we want is not water soluble. All the other ones are. Piece of paper. Anyway, the other ones are soluble, which means I can just pour, if I think I'm done, I can just pour all of this through like a paper towel or something, and this component that we want will get stuck on the towel, which means that we can just easily get it out. So let's see if I can replicate the same results as the first time I tried it. Oh, here it is, my lab. And here is the apparatus I'm gonna be using. Wait. By the way, I took out the wires like a few days ago, and now I'm gonna add another one back in. So this is how I made it. On both sides I've just folded the copper wire over and over. This is not great, but it isn't terrible. I'm just gonna use it. And by the way, here's the sodium bicarbonate in it. Now I'm gonna fill it up with water and see how it does. And by the way, this is a one-way valve. I used it to get the gases out I wanted to get it in this, but that didn't quite work. And then the one-way valve broke off, kind of. But anyway, that's not really important. Let's get to it. So now I have set the voltage and amperage to the maximum and turned it on. It's powered on, and let's go. That was just a demonstration of off. Dang. Maybe I should turn off the power really quickly. Thank you. Now, a second. Now, look at this. Oh yeah, you can see it getting blue already. Oh, this is beautiful. You can see it getting more blue, the anode, just as predicted. And now let's just let this run. How many volts do I have? 17 volts at 5 amps. Damn, that is a lot. So anyway, we are pulling 8 watts. Yeah. Ooh, it is again getting this deep blue with beautiful color. Hold up, let me just get you in a different perspective. Would you look at that? So beautiful. And by the way, how I'm gonna do this, I'm gonna take a... Wait, what's the word for this? I don't know. I'm gonna put a paper towel in it, let the whole, liquid run through, and then we will have a beautiful copper hydroxide. So now I will let it run a little bit more. You know what? I will check on the cathode and the anode right now, just for safety. So you can see the anode has gotten very blue because the copper ions settle on the anode. Now I will have to find a way to get that off. I think I will just scratch it off with a Stanley knife. Wait, which is this one. So the anode is at least kind of cleaned again. You can see it a little bit there. But the thing is, while scratching away the copper hydroxide, I came to the conclusion how I will then do it. I will just do the same thing over again until this is completely like... By the way, the reason I'm scratching the copper hydroxide off is because it conducts electricity really badly. Okay? May kind of seem counterintuitive at first, but anyway. So, now I will do the same thing over again, but then I will switch the cathode and anode, so the other side is the anode and gets all the copper hydroxide. Because, I think this is then gonna be enough, because look at this really great color it already has. And this like about 1.5 times, because the tries now are gonna be not as efficient. Anyway, let's get into it. Oh, wait, this is not properly done. Wait, I'm sorry, you have to see this. Yeah, now you have it. So, wait, yeah, this is the anode. So right for me, oops, the camera is not perfect. Right, now it is better. Here is the positive side again. By the way, anode is always positive and cathode is always negative. By the way, anode is always red. Not always, but most of the time the anode is red and the cathode is blue. Let's turn it on. Yeah, I can hear it again. This is so interesting. That all of this was just an accident. This is just insane. As soon as the voltage rises, What the You hear that? Okay, the voltage is rising now really much. What the hell is that sound? It's like, what the? Yeah, I'll turn it off now. I wonder how this looks like. This looks like right now. Yeah, it's basically completely covered. Oh, has the solution gotten warm? Yeah, this is really warm. Ah, this is this feels good. Let's switch the anode and cathode and keep on going. Well, maybe the jar is still warm because I poured in warm water so the sodium bicarbonate dissolves more easily. Good. Let's turn it on. I don't hear yet this. I really hope you heard it. Wait, hold up. Why is this at 30? What the fuck? Oh, this is at what the This is at 61 volts now and only an amp. Oh, what happened here? Oh. Yeah. According to my plan, before I should have switched the cathode and the anode, I should have scratched off just a little bit of the copper hydroxide so the electricity could flow better. Yeah, we got enough copper hydroxide anyway. For the first run it's okay, I think. So, let's get it off here. Okay. Thanks. Oh yeah. No, what the? What? Yo, this is really interesting. Now we can see. Wait, let me just clean it up a little bit so it doesn't like drop everywhere. Oh, the blue color. You can look at it in a second, but just check out this really quickly. Get out. Ugh, why is this so black? That looks gross. That doesn't look beautiful. Ugh. Anyway, now, you know, before, this was the anode, the positive side, which the surface of it turned into, well, it didn't turn into, but you know, before the anode got covered in the copper hydroxide, and now I switched around it, so the before cathode was now the anode, but there's like basically no blue on the before cathode before. Really interesting. I think basically the copper hydroxide traveled from the anode to the cathode. Wow, I didn't expect seeing this. But what is this black thing? Wait, hold up just a second. Let me see if it conducts electricity. Wait, as soon as I touch it with my, you know, thingies, this little coat extremely quickly wears off. But right now, I think like 1 centimeter had 200,000 ohms. So whatever this is, this does not conduct electricity at all. So wait, let me try again here. Really soft. Yeah, that was not really soft. 0.2. You know, it always is at 0.2 million ohms and then just falls down. Confusing. I will do some research and get to you about this. Now, let us get the results. Assault? What the hell am I saying? So now I have strained the results as I've told you I would, and basically here I have it, the beautiful copper hydroxide. Well, it is a little bit poisonous, but that doesn't really matter. Well, it does matter, but I'm not gonna ingest it in any way. But all copper compounds are kind of poisonous because copper is, well, toxic. But now, what kind of confused me at first is that even though I strained the thing that was supposed to be greenish blue, the copper hydroxide, this water, that's water, you know, that came out of the filter was still blue, but I saw no chunks in it, which was weird because the copper hydroxide is actually not water soluble. But turns out this is when the copper ions form and have another reaction, which is also this kind of blue. You know, interesting that copper itself is like has this red orangey color, and then all of its like, you know, compounds with it in it are like kind of blue, because copper sulfate is blue too, and copper chloride is also blue. At least those are the ones I know it of. So now what will I do with this copper hydroxide? I have no idea. You write it down in the comments. Thanks for watching the whole video, by the way, and if you liked the video, again, like and subscribe, it would really help me. I would appreciate a lot, but now, yeah, basically that was it. I'm kind of thinking about making copper sulfate another time, which takes more work, but you know, I do that because copper sulfate looks even more beautiful. Okay, only problem is because I create hydrogen sulfide, which is very poisonous. But you know me, maybe. But yeah, I really don't know if I'm gonna make it, but maybe. Let's see, okay? Bye.